Imagine you wake up tomorrow night, look up at the sky, and the moon is just a tiny bit farther away. No big deal, right? But what if I told you the moon was actually drifting away twice as fast as it does today? That little cosmic slow dance between Earth and its moon would suddenly speed up, like hitting the fast-forward button on 4.5 billion years of history. Right now, the moon is already sneaking away from us at about 3.8 centimeters per year. That's roughly the same speed your fingernails grow. You'll never notice it in your lifetime, but astronomers with lasers and mirrors can measure it. Now, let's double that rate. Instead of 3.8 centimeters, the moon pulls back at around 7.6 centimeters per year. Still tiny, still invisible, but over millions of years. That's a completely different story. The moon controls our tides. Without it, surfing would be boring, fishing would be harder, and beach houses would be slightly safer. But doubling its getaway speed means the ocean's rhythm changes faster. High tides get a little weaker, low tides less dramatic. Eventually, Earth's coasts would look calmer. But don't celebrate just yet. Less tidal movement means less mixing of ocean water, which could actually harm marine life. Many species depend on tides for food and reproduction. So, doubling the moon's speed is basically doubling trouble for crabs, turtles, and the entire seafood menu. Here's the weird part. The moon isn't just drifting, it's stealing. As it leaves, it takes a little bit of Earth's spin energy with it. That's why our days are slowly getting longer. Right now, we add about 2 milliseconds to the length of a day every century. Double the moon's speed, and we double that slowdown. Fast forward far enough, and days stretch out to 25, then 26 hours. More time to sleep and sounds amazing, until you realize our biological clocks, farming schedules, and climate patterns are all tuned to 24 hours. A longer day could throw everything off, from crops to your morning alarm. One of the saddest parts? The moon would slowly look smaller. It already used to be huge in Earth's early sky. Imagine filling up half the horizon. But as it drifts faster, it shrinks in our view even quicker. That means no more total solar eclipses way sooner than expected. Instead of the moon perfectly covering the sun, we just get a meh ring of fire. Astronomers predict eclipses will vanish in about 600 million years at today's rate. Doubling the drift? Cut that time in half. Sorry, future humans. You'll miss out on one of nature's coolest shows. Okay, here's the real kicker. If the moon drifts too far, Earth loses its stabilizer. Right now, the moon acts like a giant cosmic weight, keeping Earth's tilt steady at about 23.5 degrees. That tilt is why we have seasons. Without the moon close enough, Earth could wobble like a broken top. Sometimes we'd tilt a little more, sometimes less, turning summers into blazing infernos and winters into frozen wastelands. Imagine crops failing, climates flipping, and species struggling to adapt. Basically, Earth would go from cozy blue planet to cosmic roller coaster. So, doubling the moon's escape speed doesn't ruin life tomorrow. But over millions of years, it changes tides, stretches our days, kills off eclipses, and eventually makes Earth's climate a mess. The moon might look like a quiet, glowing rock, but it's secretly our planet's life coach, keeping things balanced. Lose it too fast, and Earth's future gets pretty shaky. So what do you think? Would you trade total solar eclipses for a 25-hour day? Let me know in the comments. And hey, if you enjoyed drifting through this cosmic what if, don't forget to like, subscribe, and hit the bell. Who knows? Maybe next time, we'll ask what happens if Earth gets a second moon.